Hey everybody, welcome to Video Notes 5.1. The last one of the semester. We're going to be able to do these three things when we're done. Chapter 6 and 7 of the book are your way to go. So we're going to be looking at chemical reactions, and here are some signs of chemical change. So you get an unexpected color change, heat is produced, heat is absorbed, a precipitate forms. This is a precipitate when you get a solid. You might get a gas or an odor. Those are just some signs of chemical change. What's a chemical equation? It's an equation that uses symbols to represent a chemical reaction. Okay. So what are the reactants and the products? Reactants are on the left side of the arrow used up, okay, in a chemical reaction. Reactants. And then products are what get produced. Products. Make sure you know that, okay? Reactants and products. After the arrow are the products. Point to products. Arrow points to products. Catalyst is something that goes over the arrow. All right, states of matter, and we'll see it on the next slide. All right, so chemical reaction, something new forms. Here are some symbols we use in chemical equations. If you see a parenthesis G, it's a gas. So you would say blah, blah, blah gas. Like if it said CO2, you'd say CO2 gas. Liquid H2O, for example. Solid, blah, blah, blah. Aqueous, blah, blah, blah. The plus sign on the left means react with. On the right side in the products, it means and. This is when a precipitate is produced. Another thing you can use for this is solid. This is when a gas is produced, but only on the product side can you use those. Arrow means yields, produces, and above the arrow is a catalyst. All right, so there's some symbols in a chemical reaction. Don't forget your 7 diatomic elements. They're always going to show up as diatomics when they're by themselves. All right, all of them are diatomic elements. Bromine is a liquid, iodine is a solid, but the rest are gases. Okay, so just to get the idea of a chemical reaction, the numbers in front of substances are coefficients. Reactants are on the left arrow, products are on the right, and there's 5 main types of chemical reactions that we're going to have to know. So jot these down. These are the types of reactions. You've already met a couple of them. You need to know them all. Synthesis, decomp, single replacement, double replacement, and combustion. So what is synthesis? Synthesis, whenever you synthesize something, you make it. What gets made? A compound out of 2 elements. Okay, so you know, like the kangaroo and the mango make the mangaroo. The turtle and the cantaloupe make the turtleope. All right. Sodium and chlorine make sodium chloride. Now you might be saying to yourself, hey, what happened to the 2? Well, remember when sodium makes an ion as a +1, chloride makes an ion as a -1. That's why it's NaCl. And then we're going to learn that we need to put a 2 there and a 2 there to finish that equation off. When hydrogen and oxygen, the elements combine, you get water, H2O. Okay. Decomposition sounds just like the word. Something breaks down, decomposes, gets smaller, blah, blah, blah. So, blah, blah, blah. A compound will break into smaller pieces. Those pieces are usually elements or smaller compounds than the original compound. So here's a compound of NH3, nitrogen trihydride, or ammonia as we know it, breaks down into its elements. Now you might be saying to yourself, what's with that 2 and that 2? So when you have the elements of whenever they're by themselves, that's when you need the 2. That's what I'm talking about. Carbon dioxide breaks down into carbon and oxygen is O2. Right? You might be saying to yourself, what do I do with the fact that there's 3 hydrogens over here and over 2 over there? Well, we're going to learn about coefficients, but we then would doing this and putting coefficients in. Okay, so how do you know what kind of reactions they are? Nitrogen dioxide decomposes. So we know that's decomp. It says right there, we don't even need the whole reaction. Calcium reacts with oxygen. This is an element, and this is an element. So this is going to be a synthesis because we have 2 elements reacting. This is just a compound. So the only thing a compound can do is break down. So this is decomp. Even though we don't know the products, we know it's a decomp reaction. Element, element. This is going to be a combination / synthesis. Because 2 elements, the only thing they can do is make a compound. Combination synthesis. All right, single replacement. Single replacement is sometimes called soap opera chemistry. My date left me for somebody better. What? Okay, so you have an element and a compound that are going to make a new compound in a different element. There's an activity series involved with this reaction, which I'll explain. The most active substance gets to replace. If it's not, then it won't. Metals can only replace metals, and that'll go in the first part of the compound. As cation. Non-metals can only replace non-metals, and that'll go in the second part of the compound. So this is the cation. All right. This is the metal. So if the metal's more active than the cation, then it'll kick it out. Look, metal hooks up with anion. Cation gets kicked out, but now it's an element. Turns into an element. Here is a non-metal. So what it's going to do is try to replace the anion part. And look, anion gets kicked out, and non-metal ends up as the second part of the compound. Okay, so you have a compound and an element in a single replacement. Double replacement is at least a little more fair, right? You change partners, but everybody still has a partner. The element that's in the front of the compound will be in the front of the compound all the time. Okay, so AB is the compound. A is in front, B is in back, C, D. Right? We notice A is still in front, but now it's with D. C is still in front, now it's with B. So these are all compounds, so we're going to have to be able to cancel charge to make these compounds. Right? So the whole unit we spent canceling charge, we need to do that again. And then reactants are always going to be aqueous, and the products, one's going to need to be a solid or water or gas. Okay, so here's some samples, and we can tell just by looking at the reactants what we have. So we have a compound and an element. This is a single replacement reaction. Compound and a compound, compound, gives you compound. We can see the whole thing here, so this is double replacement. Compound, even though we don't know the products, we know it's going to be a double replacement. Potassium iodide is a compound, reacts with fluorine gas. Okay, that's an element, so a compound and an element is going to be a single replacement. The last type of reaction is called a combustion reaction. Combustion needs oxygen, so a reactant has to be there, reactant. The other reactant is a hydrocarbon, a compound with C's and H's. C's and H's. Now, here's the cool thing about the products of this. They're always going to be carbon dioxide and water because we're assuming complete combustion. Okay? So here's the generic or general equation. General. So you have carbon and hydrogen in a compound. Could have oxygen maybe, but you have to, well, you can write have to have O2 gas as a reactant. And look, products are carbon dioxide and water. Yeah. Oh wait, is that your lab report? Don't do that. Even though it's a combustion reaction. Okay, here's some samples. Methane burns, so we know this is going to be combustion, even though we don't see the fact that there's going to be O2 gas. And we don't even know the products, we still know it's combustion. Here we have a hydrocarbon, HC compound, and O2, yay, oxygen gas. So we know this is also combustion, even though the products are carbon dioxide and water. We didn't even need to see those to know it. Okay. Sugar burns. So we're going to have, hey, what's happening to you right now? So they have energy to do this video notes. Yay. All right. So we know this is combustion. Okay. So those are the 5 types of reactions, and that's how you recognize them. And you could just see the left side, right? Just the reactants and decide. And you could see the products and decide. So you don't need the whole reaction to do it. But if you just see the reactants, combination is 2 elements, decomp is 1 reactant, single replacement is an element and a compound, double replacement is 2 compounds, combustion is hydrocarbon and oxygen. So decide what these are. Well, let's see, we got elements and an element. I think it's combination, right, which is the same as synthesis. Compound, double replacement. Compound element. Compound element. That looks like single replacement. But wait, double check if the compound is a hydrocarbon and the element is oxygen. Combustion. So be careful with that one. This is a compound, so it's going to decompose. And this is an element and a compound, and it's not a hydrocarbon, so this is a single replacement. All right, so review and recognize these. And we just have one more thing to do. Law of conservation of mass. This is a law. Okay, so this guy's thinking. He's thinking about chemical reactions. You can't create or destroy matter in a chemical reaction. The atoms just rearrange. Right? So if you have 10 atoms going into a reaction, you better be able to find those 10 atoms on the other side. So if I have 2 green atoms as a reactant, reactant plus reactant, and the arrow for products, right, I'd better be able to count 1, 1, 2, 2, 1 big purple. All right, so it weighs the same going in as it does coming out, but it has different properties because it chemically reacts. So here's a balanced reaction for, hey, what is this? Looks like combustion to me, baby. Yeah, combustion. All right. So here's one molecule, C3H8. Here's 5 oxygen molecules. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 total oxygens. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 total oxygens. So here's the thing. The chemical identity has to stay the same. So I couldn't just write O there. Okay. These are oxygen molecules, so they come in packs of 2 oxygens. Carbon dioxide comes in packs of 1 carbon and 2 oxygens. But these coefficients tell us how many of each molecule there are. There's 1, 2, 3, 4. 1, 2, 3, 4. So every atom has to be on both sides of the reaction, even though it's rearranged. So a subscript tells you how many atoms are in your molecule. All right, so 2 C's, 1, 2, 3, 4, 5, 6 H's. All right. That's the molecule. We can't break that up on one side of the reaction. It breaks up to make something new on the other side. So state how many atoms are in each. This is a compound, CO2. So we saw this already. How many carbon atoms? 1. How many oxygen atoms? 2. How many nitrogen atoms? 2. Hydrogen atoms? 2. Carbon atoms? 1. Oxygen atoms? 3. So you got to be able to count these. Potassium atoms? 1. Manganese? 1. Oxygen? 4. So that tells you what the molecules are made of. Okay. Coefficients multiplied by the number of those particles. So there's a coefficient of 1, a coefficient of 1, and a coefficient of 2. So here's an H2, here's a Cl2, here's an HCl. Right? But we need 2 HCl, so that we have 1, 2, 1, 2, 1, 2, 1, 2. So this is a multiplier times that. All right, so they're the same things with coefficients. Now we have a coefficient. So we have 2 times 2 is 4 oxygen atoms and 2 carbon atoms. So we had 2 nitrogens times 3 is 6. 8 times 3 is 24. 3 carbons, 9 oxygen. Okay, 6 potassium, 6 manganese, and 24 oxygen. So the coefficient is a multiplier, but it has to multiply by everything. Okay. So balance these equations. So I have 2 H's over. I like to list them. You don't have to do this. It's just a technique you can use. In this compound, in this reaction, I have H's and O's. On this side, I have 2 and 2, and this side, I have 2 and 1. So I need to make O's even, so I'm going to put a 2 there. But that changes everything to 4. Don't add to it, just cross out and count again. Uh-oh, now I need more hydrogen on this side, so I put a 2 there. Don't add to it, just count over 4, and then, yay, it's balanced. Okay. In this one, I have N's and H's. So I need 2 H's over, 2 N's over here. Okay, let me restart this one. We'll start with what we have, 1 and 3, and then 2 and 2. All right, so let's see. I need 2. I don't add to it, I just count over 2, and then that makes that 6. Uh-oh, now I need more H's, so I put a 3 there, and then that just changes, we count 6, and then it's balanced. That's the happy balance. Okay, so make sure you can write and balance equations. Law of conservation of mass. Identify the 5 types, and then know the symbols of chemical